All right, today's topic is topic 1-2, systems of equations. During this lesson, we will define a system. We will explore two methods of solving this system of equations. Hopefully, we'll get a better understanding of when to use systems of equations and which method would be preferable in order to solve such. Now, again, this is an Algebra 1 lesson, but this should give us a good recap. Make sure that we're on pace and ready to get going in geometry. We'll start out with systems of equations. All right, let's start off with the first thing we really need to look at here is what is a system. And on your paper, you will see this. It will have a system. And we're looking for a definition, so we need to write this down. We need to think of what a system is. And a system is defined as, let me go ahead and grab this color here. The system is defined as two or more equations of lines. Two or more, that's the key word there. It could be more. Equations of lines. The solution where would you think the solution? What would the solution of these be? Well, if we've got more than one system of lines here, we've got these two lines. A solution to such would be right here where they intersect. The solution is where they intersect. Make sure you have that written down. That is the big key. A system, two or more equations of lines. The solution to which is where they intersect. We've got two lines. That is where they will be intersecting. Now, another thing that we need to note on this, another thing that I talked about a while ago, is what we need to look at. When we have these systems, you can solve it in one of two ways. Two methods to solving. The first method of which we are going to solve. And this can be you can choose either one of these. Both of these will work for any set situation. The only thing is one might be easier than the other for each given set. So they can be used by two things. Let's see if you know what they are. First one. We have elimination. Elimination, as it means we're going to eliminate one of them. Typically, in a set of or a system of these equations, you're going to have multiple variables. You can have an x and a y. You can have an a and a b. You can have an a and a y. Whenever we're going to eliminate, we're going to set two or more equations up together, and we are going to eliminate one of these. That way we're only working with one. If you get to where you can only work with one variable, you'll be able to solve for that variable. When you solve for that variable, you can substitute it back in, which leads me to our second method. Our second method. I just said it. Second method is substitution. Substitution. And that is saying that we can substitute something in for a variable. Say you have an x and a y. Well, if we say x is equal to 3y, now we can substitute this can be, and I talked about it on the previous lesson, say our original equation is 6x equals 2. But we know and I know that's a bad example because there's supposed to be a y in there. But let's say we have this that we're going to substitute this in for. So now, here, let's make it, there we go, 6x equals 2y. Now, when we're going to substitute in, we would put 3y in where we see an x. So, let's say 6. Hey, there's an x. So now, grab this, I'm going to put 3y equals 2y. Now we can solve that out. The reason we can solve this is because we have one variable, just like what I was talking about right up here. Draw my little arrow. We're looking to get one variable. Here we're going to eliminate and work with one variable. Here we're going to substitute another variable in for this variable, so that way we can work with one variable. So that defines a system. System, two or more equations of lines. The solution is where they intersect. Now these can be solved using either elimination or substitution. All right, now working through our examples. If you look at your paper, you should have 5 examples. I'm going to work through the odds. I expect you on your own to work through the evens using what you learned from the previous odd to work the problem. So we're going to start here. We've got example 1. Let me make sure I'm ready to write here. Example 1, it tells us to solve, and it gives us a system of equations here. It has an x plus 2y equals 2 and a 2x plus y equals 4. All right, so I'm going to look at solving these, and I'm going to go through this on both ways. I'm going to solve by let's solve first by elimination. All right. So we're going to eliminate one of these two variables. I'm going to rewrite here. I'm going to say x plus 2y equals 2, 2x plus y equals 4. In order to eliminate, whenever we're going to do elimination, we're going to add these two together. So in this case, we have a positive x and a positive 2. 2x plus x equals 3x. Does that eliminate it? No. Let's look at our y's. 2x, positive 2x, positive y, 2x plus, 2y, we've got a y, 2y plus y, add those together, 3y. Does not eliminate it. So we're going to have to do some work. We're going to have to change this up a little bit. Now there's a couple of things that you can do here. You can, if you want to get the y's, let's shoot for the y's. We're going to leave the x. We're going to remove the y's. We want this y, first of all, to be a negative, because it's got to be opposite sign of this one up here. And second of all, we've got to have it equal to a 2y. So it's got to be a negative 2y. In order to get this to a negative 2y, we can't add or subtract. We have to multiply or divide. What would we multiply this by to have y equal? We want y to equal a negative 2y. Well, right here, say we put parentheses around it. We multiply by negative 2. Now, what we do to one half of this, we have to do to the other. So I'm going to put a negative 2. That's what we're multiplying by. Negative 2. That's what we're multiplying by. We have to do this throughout. So whenever I rewrite this equation, I'm going to take my negative 2 times 2x. Negative 4x. Negative 2 times y. Negative 2y. And here we're going to have equals negative 2 times 4, or negative 8. All right. Now, it doesn't matter what order. I had this one on top. I'm going to move this one down below this. So I'm going to have an x plus 2y equals 2. Now, can we eliminate right here? Does this work? We can take this. We can draw a line through it. Those will eliminate when we add through. Now, let's go ahead and do some quick math. Negative 4 and a positive y. Negative 4 plus y, positive x. Negative 4x plus an x. So we've got a negative 4 and a positive 1. Negative 4 plus 1. Negative 3. There's our x. This has been eliminated. Equals negative 8 plus 2. Negative 6. Now, let's solve for x. We worked that before. divide by negative 3, divide by negative 3, x equals 2. Positive 2. We've got two negatives. Two negatives give a positive. So x equals 2. So now we can come over here and we can substitute this in. Let me go ahead and erase this. Erase my little mark. I'm going to take this and I'm going to substitute everywhere I see an x, I'm going to put a 2. And the special key thing about this is we only have to do this to one of these equations. We don't have to do it to both. We can just do it to one of them. We can do it to whichever one is going to leave us the easier solution. Now, I'm going to look at this. I'm going to say, well, I'm multiplying by y. I'm going to have to get my y by itself because the x is going to be gone. Here, I don't have anything with the y. This one would actually be easier because I won't have to divide. I can just have a y equals in the end. So I'm going to take this equation and I'm going to rewrite it. 2, hey, there we go. There's an x. So we come down here. 2, substitute that in. 2 times 2 plus y equals 4. All right, so let's look and see what we've got here. 2 times 2 is 4 plus y equals 4. Subtract 4 from both sides. Y is equal to 0. We have it solved. Now, all you got to do is you got to take, we're going to put this, whenever we write this, we're going to write it as an ordered pair. Parentheses. Our first thing that comes first in an ordered pair is an x. Our x value is 2. 2. Our second value is our y, so 0. There's your answer. Draw you a box around it. Problem solved. Now, we go here and hide this layer, bring this layer up. I'm going to rewrite this equation. I'm going to work it one more time, and we're going to do substitution. So x plus 2y equals 2. 2x plus y is equal to a 4. Now, I'll work it through. Substitution. Substitution is going to be a little bit more difficult on this problem. I'm going to take my problem, and I'll take either of these two, and I'll go ahead and set it to an x equals or a y equals. So I'm going to go ahead and take my first one. I'm going to set it, I'm going to have x plus a 2y equals 2. I'm going to set this equal to, I'm going to get this x on one side. So I'm going to move this y over. Subtract a 2y. Subtract 2y. X equals 2 minus 2y. Okay, there we go. We've figured it out. X is equal to 2 minus 2y. So let's take this and we're going to put it in our second one. We can't put it back in our first equation that we used. We have to now put it in this right here. We'll have to put into this equation. So I'm going to rewrite this equation down here. I've got 2. Hey, there's an x. So now I know I'm going to fill this right here in. I'm going to put this in parentheses 2 minus 2y plus y equals 4. Let's do the math. Distribution. The distributive property. I have to take this to everything inside. 2 times 2 is 4. 2 times negative 2y. Big mistake is forgetting this negative. 2 times negative 2y. Negative 4y. Now it's out of the parentheses. Plus y is equal to 4. All right. So now let's look at solving. Let's go ahead and let's use combine our like terms. Combining the like terms. So I'm going to rewrite. I'm going to move this over to here. This ought to give me plenty of room to work it. I'm going to leave my 4. Our like terms are our y's. Negative 4 plus a y is going to leave us a negative 3y equals 4. All right. Subtract 4 from both sides. Negative 3y is equal to 0. Divide by negative, erase this, 3. Divide by negative 3. Now, you divide 0 by any number. What do you get? You get 0. Can you divide negative 3 by 0? You cannot divide any number by 0. That is one of those math taboos. It does not work. You cannot divide by a 0, but you can divide 0 by any number, and you will always get 0. Y is equal to 0. Now let's take this, now that we have that knowledge, and let's substitute it back into our first equation. Let's see. X plus 2. Hey, now we've got a y times 0 is equal to, and go over here and get my green, 2. Okay, so now we have x. 2 times 0 is 0, plus 0 equals 2. Might as well go ahead and remove this. X equals 2. I'm going to rewrite my solution set. With that being said, we're going to have a 2 and a 0. Now, if you look back at what we did, or remember if you didn't happen to write that down, 2, 0, that is our solution. Alright, so now that we've looked at example 1 and we solved it through 2 different methods, we've proven that either method will get you to the correct answer. So now we're going to look at example 3 and example 5. And on these, we're going to just do one method. We're going to look for the method that's going to work out the best for that set of equations, and we're just going to use that one and solve. So example 3 is 2x plus 3y equals 5. 2x plus 3y equals 5. And then our second one is a 5x plus 4y equals 16. So here we have to look at 2 things. One, a good thing for substitution is to find any of these variables. It doesn't matter which one out of all 4, 5, 6, how many variables you have that does not have a number attached to it. Because if we wanted this y right here by itself, we would have to divide by 4. We'd have to divide everything here by 4 in order to be left with just a y. So it can get to where your fractions, it could cause a mess when doing this. But it also, whenever we look at this, now we're looking at what we can multiply a 2 and a 5. We need to get these things with their x to be the same. You can't multiply anything off the top of my head to get 2 multiplied by what gives you 5. That's very difficult to answer. Now, 3 multiplied by what gets you 4. Another very difficult answer. So, you would have to look at what you could go up to. An easy way of doing it is say we want to get our x's the same. Well, let's multiply this by this number. So up here we'll multiply everything by 5, and down here we'll multiply everything by 2. We know that that will give us a very common answer. We'll both have 10s here. Now 1, in this instance, will have to be negative. 1 will have to be positive. So in this solution here, it really is kind of a toss-up. I'm going to say the easiest one, instead of having to deal with fractions, is we go ahead and we set an elimination. So I am going to draw that in. We're going to multiply this one right here by, I'll make it the negative 5, a negative 5 over here. Now this one here, we're just going to multiply by 2. Keep it positive, that way our signs will be the same. 2. I'm going to rewrite my equation now. Take this negative 5 to every variable, every number, everything. Everything that's in this has to be multiplied by negative 5. 2 times negative 5, negative 10x. Negative 5 times positive 3 minus 15y equals negative 25. Second one, we're going to multiply everything in here by 2. So don't just sit here and quickly go, okay, there's my 10x, now I'm going to rewrite my plus 4y. No, you got to multiply 2 times 4, positive 8 y equals 16 times 2, 32. Now let's do our math. We can eliminate our x. We will just be left with a y. And let me grab another color here to do this. Negative 15 plus 8 is going to leave you a negative 7y equals, now let's do our math right here, 32 minus 25. What does that give you? Oh, wouldn't you know? Gives you a 7. Divide by negative 7, divide by negative 7. Don't forget your negative. Y equals 7 divided by negative 7. The answer will be negative. Any number divided by itself is a 1. So our y is equal to a negative 1. Let's take that back up. We do not have to plug that in right here. We do not have to do that. We can take this now and we can take it up into either of these two. Whichever one is easier. Go back to a different color. Write this down over here. 2x plus 3. I ran into a y. Let me grab my color for that. Substitute in a negative 1. Got a little carried away with that color. Equals 5. Alright, so now let's look at, erase that. Let's look at solving. 2x, multiply it out, minus 3, because we got a negative 3, equals 5. Alright. Add a 3 to both sides, add a 3 to both sides. 2x equals 8. Divide by 2, divide by 2, x equals 4. So now your solution for negative 1. Now, say you're unsure of such. Well, let's go ahead and let's plug these in. And grab a color. We'll plug these in. Right over here. 2. There's our x is 4 plus 3 times negative 1 equals 5. 8 minus 3 equals 5. 5 equals 5. That works out. If you plug this in to this second one, you will find the same thing. Alright, now let's real quickly, let's look at example 5. Example 5 gives us 2x plus 5 y equals 10. And then we have a 6x plus 15 y equals 30. Now, granted, you have this on your paper, but still, it's a good habit to go ahead and rewrite it, because when you rewrite it, you can put it in whatever order you need. You can get it lined up. That way you're not working, especially in these examples. Otherwise, you'd be working right in the middle of the page. Move this over to the left side, rewrite them. Now, there's no easy way to get to our substitution. We're going to have to divide. You're going to have 5 divided by 2. Not going to get you anything good. 15 divided by 6, not going to get anything good. So let's look at our eliminating. We're going to eliminate our x real quick. To eliminate that, this gives us something real easy. We can multiply 2 times a number to get 6. That number is 3. Now, do we want to multiply by a positive 3 or negative 3? Negative 3, because we need this to be negative. Negative 3 here. Now, when doing this, I'm not going to mess. I don't have to touch this second equation. If you don't have to touch it, just leave it written down as it is, and let's go ahead and let's do the math. We'll rewrite the top equation right below the second equation. 2 times negative 3, negative 6. Keep our x. Negative 3 times 5, negative 15. Leave our y. And negative 3 times 10 equals negative 30. Okay, by now, hopefully you've already caught what is about to happen. What is about to happen? Whenever we eliminate these, we're left with a 0. When we eliminate these will also eliminate. They'll leave us with a 0. And so will these. These will eliminate a 0. Now, the key thing to this can happen. This is common. what you've got to look for is one of two things will happen. In this instance, a 0, you can plus, you can minus a 0. It doesn't matter. It doesn't change it. These are zeros. 0 equals 0. Is this true? Does 0 equal 0? Yes. Yes, it does. That is true. If it is true, if you can say this is true, this will be infinitely many solutions. We will have infinite solutions. Now, what does it mean by infinite solutions? If we were looking at two lines earlier and we were looking at where they met, this is saying this thing is just, this will always meet. There's a bunch of these. Well, how can there be a bunch of these if they intersect and if they don't follow the same line? So, for an infinitely many or infinite solutions, there's both lines. Both lines are stacked on top of one another. They are the exact same line. Whenever you work these down, these things will be the exact same. Now, what's on the flip side of that? If you happen to do this, and let's say, for instance, this last number, instead of a 10, happened to be a 4. Negative 3 times 4, that's going to get you a 30 minus a 12. Okay? 30 minus 12 is going to give you an 18, and it equals a 0. Does 0 equal 18? Because 0, this would have zeroed out on this entire side. Does 0 equal 18? No. No, that means there are no solutions. And if there's no solutions, that means, let me draw a no solution set. A no solution, no solutions, no solutions lines. I know it's tough for me to draw on here, but no solution lines are parallel. They will never touch. This line will go on infinitely in this direction, and so will this one, and they will never touch. This is our infinite solution. It is all the same line. Infinite solution is same line. Write that down. All right, now that we have completed all of our examples, ending with how to determine whether our solution would be infinitely many or no solutions, let's turn back and let's look at a real-world example of using a system of equations in order to solve. And for the sake of time, I already have one of these made. It says, at the concession stand, you are selling hot dogs and sodas. Each hot dog costs $1.50, and each soda costs 50 cents. At the end of the night, you made a total of $78.50. You sold 87 hot dogs and sodas combined. And now the question, how many hot dogs and how many sodas were sold? Now, what we've got to do on this is we've got to pull out bits of important information. Now, for this example, I've already highlighted for you what we have. We have our hot dogs, sodas, we have our prices, we have a total, which is going to be something different. We've got to pull out variables here. What are the two variables? Two variables are going to be in the questions. It asks how many hot dogs and sodas. That's where you're going to get your variables. So I'm going to write down, we've got our hot dogs, and we've got our sodas. Now, we can put any variable. That's the magic of it. We can put any of them in. To keep with what we're doing, let's highlight our hot dogs be an X. Our sodas will then stand for a Y. Now, we have to pull two equations out of this. It says hot dogs cost $1.50. So if I came up here and I was going to write down an equation, I could say $1.50 per the hot dog. Our hot dog is an X. And we know a soda is 50 cents. Now you want to find a total of something, because here's keywords, total. If you want to find a total, you're going to add or you're going to subtract when you're talking about bringing in money. Well, you're going to add them together. If somebody says, okay, well, I want to buy a hot dog and then a Coke, well, you don't subtract the price of the Coke from the hot dog and get a total. No, you're going to add them together. So we're going to add And we're going to add our soda. And a soda, as it tells us, is 50 cents per soda. Soda stands for Y. And we know our total. We know what they all added up to. It added up to 78.50. Now, secondly, we have to have two equations. It tells us that we have 87 hot dogs and sodas combined. So if we combine our hot dogs and our sodas, now whenever it's one hot dog and one soda. You combine one of each of those, you combine all that we've sold, and we're going to get 87. So our equation will be an X plus a Y because there's only one hot dog there and only one soda, and we know that the total was 87. So now using this, we can now use substitution or elimination to solve. Let me get rid of our question. We're going to leave this up here, and now we're going to look at solving. Now, we don't have anything with an X or anything with a Y. It's really easy at that point to use a substitution. In order to use substitution, we're going to get one of them by itself. It doesn't really matter which one. I'm going to go ahead and let's get a Y by itself. The only reason I'm picking that is this is going to be in most general cases, the least complicated term to multiply to because there's nothing in front of the decimal. So if I'm going to get my Y by itself, I'm going to subtract an X, subtract an X, Y equals 87 minus X. Now I'm going to rewrite this equation, the first one, because since you can't use this one, rewrite the first equation, substituting this in. 1.50x plus 0.5. I guess we can leave off the zeros. I'll start with that right now. We've come up to a Y. We have a Y equals. We're going to be substituting that in. Let me go grab my substitution. 87 minus an X equals 78.5. Dropping off the zeros. Now let's do our distribution, which if you're multiplying by 0.5, 0.5 is saying is 1/2. If you multiply by 1/2, you're going to divide by 2. So 1.5x 87 divided by 2. Just so that way we can see the math. We're going to look at that. That will go in there 3 times. That will leave you a 6, 1, and a 0, 5, 43.5. That is a positive. Positive 1/2. Positive 87 plus 43.5. Multiply 0.5 times a negative x. Negative 5x equals 78.5. All right. Minus a 43.5. We can also go ahead and combine our like terms. We can speed this up. A negative 0.5x here and a positive 1.5. So 1.5 minus 0.5 gets you just 1. So we just have an x. We just have an x over here. We're going to subtract both 43.5 from both sides. X equals, do our math over here, 7 minus 4 gives you a 3. 8 minus 3, 5. There you have it. We've got our x. X is equal to 35. Now we can take that and let's substitute it back in. This will be the easy one to do. We can do it on either one, but this one will be very easy. So, I'll leave the same color here. 35 plus a y is 87. Subtract 35, subtract 35, y equals a 52. That's kind of a rough find, but that is a 552. Let's check that. We can put it in right here. We've got 35 plus plus 52 equals an 87. 87 equals 87. That checks out. If you would like, go ahead and put it into your calculator. Put it into your calculator right here. 1.5 times 35 plus 0.5 times the 52. See what you end up with that right there? That'll be your result. Now that we have that, the last thing that we do need to say off of that, we know our x is equal to 35. So our original question was how many hot dogs are sold? Hot dogs. We have 35 hot dogs that were sold. And we have 52 sodas. That is our final answer to this question of how many hot dogs and how many sodas were sold.